Dear students, in the previous episode, we have seen how air masses and fronts have served as a background for a clear understanding of atmospheric disturbances. Extratropical temperate cyclones and anticyclones and tropical cyclones are the good examples of such disturbances. In this episode, we will be presenting on the temperate cyclones and anticyclones. Atmospheric disturbances are the results of the complex process of exchange of heat between different latitude zones. Maximum disturbances are noticed in the middle latitudes. Therefore, we will discuss about the extratropical or temperate cyclones and anticyclones. The episode consists of the following modules: cyclones and anticyclones, extratropical cyclones, path and movement of extratropical cyclone, extratropical anticyclones, and types of anticyclones. Cyclones and anticyclones. We usually associate cyclone as large storm which occur in the tropics and may move north into the temperate zones in the form of hurricanes or typhoons. However, cyclones occur at any latitude and in any climate. Those that originate within 30 degrees of equator are tropical cyclones. Those found above 60 degrees north or south of the equator are Arctic or polar cyclones. The cyclones which occur between 30 degrees and 60 degrees latitude are called extratropical or temperate cyclones. Tropical cyclones that move north into the temperate zones eventually become extratropical cyclones. The atmospheric disturbances which involve a closed circulation with a low pressure center are called anticyclones in northern hemisphere, and the circulating winds in a clockwise in the southern hemisphere are called cyclones. There are two broad categories of cyclones: extratropical cyclones and tropical cyclones. Extratropical cyclones. We come across cloudy weather in temperate zones. This is as a result of cyclones in mid-latitude zones. The term extratropical, temperate or depressions are used to denote the moving cyclones in the mid-latitudes. Since the mid-latitudes are the areas of convergence where contrasting air masses gradually meet, it is there that the cyclones and anticyclones travel with westerly winds as centers of convergence, and the rising of air produces cloudiness and precipitation. Extratropical cyclones develop in regions lying between 30 degrees to 60 degrees north and south latitudes, where polar and tropical air masses meet and form what is known as polar front. On the weather map, cyclone is shown as a low pressure area enclosed by a number of isobars. They are circular or elliptical in shape. The shape and size of the cyclones. There is a great degree of variation in shape and size of a mid-latitude cyclones and anticyclones. Generally, the isobars are circular or elliptical, but in certain cases the isobars take the shape of the V. The axis of this type of depression is oriented towards southwest to northeast direction. The diameter of the temperate cyclone varies from 160 kilometers to 3,200 kilometers. But most of the cyclones have the diameters measuring 300 to 1,500 kilometers. The estimated area covered by an average cyclone in United States is about 1.6 million square kilometers. The vertical extent is about 10 to 12 kilometers. The air pressure in a cyclone is lowest at the center and increases towards its outer margins. The strong cyclonic circulation may have pressure as low as 940 to 930 millibars. The pressure differences between the center and the outer margins of low may vary from 10 to 20 millibars. Path and movement of extratropical cyclone. The mid-latitude cyclones are subjected to the general westerly flow of atmosphere. The heavy concentration of storm tracks in the vicinity of the Aleutian and Iceland in a low are the most important paths followed by the mid-latitude cyclones. There is a seasonal shift of the path of cyclone and there is a latitudinal shift. During winter months, opposing air masses have greater contrast, hence there are several cyclones originating in the mid-latitude zones and with greater intensity. Besides, since there is a greater variation in weather between winters than summer in the temperate zones, most of the cyclones and anticyclones in the westerly wind belt may move from west to east. The weather forecasting observers see the west in predicting the weather. On an average, the cyclones may travel a distance of about 1000 kilometers per day. Sometimes it varies from 500 to 2000 kilometers per day. The cyclones invariably move towards higher latitudes, whereas anticyclones originating in the mid latitudes mainly travel towards the equator and the subtropical region. The most favorable areas for the rejuvenation of weather storms are Colorado and Alberta. Cyclones forming in Canada move southwards to the Great Lake regions and then they turn towards the northeast and move out into the Atlantic Ocean. Great Lake regions are the strongest regions for cyclones in North America. There are two major regions in North America where the temperate cyclones originate. They are Sierra Nevada regions and eastern Colorado regions. These storms move towards the Great Lake regions and they produce heavy rain and snow. Great Lake regions are the breeding regions for a number of winter storms because of the steep temperature gradients. The Gulf of Mexico is another region where a number of such storms originate. In Central Europe, a large number of winter cyclones develop over the Baltic Sea. Cyclones move towards higher latitudes, whereas anticyclones originated in mid latitudes travel towards the equator and subtropical regions. Most of the temperate cyclones originating in North Pacific off the eastern coast of Asia move northward towards the Gulf of Alaska, where they merge with Aleutian lows. In the northern hemisphere, during the winters in the temperate zone, a number of storms which form over the Mediterranean basin move northeast towards Soviet Union and as far as North India. In summer, there are no temperate cyclones in the subtropical regions, whereas in the southern hemisphere over the Antarctic frontal zone, storms occur all the year round. Origin of temperate cyclones. It was toward the end of the First World War that the Norwegian meteorologist Wilhelm Birkenes and his son J. Birkenes studied the structure of cyclones in Europe. Their efforts brought about major advances in the understanding of extratropical cyclones. The theory that they put forth is called the Birken's theory of origin of cyclones. Cyclones originating to Birken's form along a front where polar and tropical air masses with contrasting physical properties are moving parallel to it in opposite directions. Middle latitudes are the areas of convergence where cold polar and warm tropical air masses generally meet. Life cycle of extratropical cyclones. There are 4 stages in the extratropical cyclones in the northern hemisphere: initial stages, incipient stages, mature stage and occlusion stage. The initial stage. In the initial stage, the polar and tropical air currents blow parallel to the isobars and the front. The direction of the cold air masses blowing on the north of the polar front blow from east to west, and the direction of the warm air masses to the south of the front blow from west to east. Therefore, the wave disturbance is produced and the front is quasi stationary and is in perfect equilibrium. Incipient stage. In the second stage, wave is formed in the southerly direction and warm air in the northerly direction. There is an encroachment of each air mass into the domain of the other. In this stage, the isobars become almost circular in shape. Mature stage. In the third stage, the intensity of cyclone increases. The air in the warm sector starts flowing from the southwest towards the cold air flowing from southeast. Now, the cyclone is fully developed. There are well marked warm and cold sectors. Warm air in this stage moves faster than the cold air. The direction of the movement is perpendicular to the warm front. In fact, the warm air is moving into a region previously occupied by the cold air. Each of these fronts are convex to the direction of its movements. If the rising air mass is moist, there will be condensation and precipitation along the warm as well as the cold fronts. Fourth stage. In the final stage of the cold front ultimately overtakes the warm front, which results in the formation of an occluded front. Finally, the two air masses mix across the front. Now the cyclone dies out. The lifespan of a single frontal cyclone is normally about 5 to 7 days. Extratropical anticyclones. Anticyclones in the temperate regions play much less important role in the weather. The term anticyclone was first used by Sir Francis Galton in 1861. It denotes an atmospheric system that is just the opposite of the cyclonic system. However, the anticyclones form one of the most important factors in weather forecasting. All the important cyclones are found over the oceans in the vicinity of 30 degrees north and south latitudes. Origin and structure of anticyclones. Anticyclones are the high pressure systems around which the wind blows clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. There are two types of anticyclones: cold core anticyclones of the northern latitudes and warm core anticyclones of the lower latitudes. These rapidly moving anticyclones move southward towards the lower latitudes. In North America, they originate in northern Canada and move southward and southeastward across the central and eastern United States. In Asia, they originate in the eastern part of Siberia and move towards China and Japan. The velocity of winds and pressure gradients is never so high in cyclones. On the contrary, anticyclones have always stormy winds. Anticyclones are always associated with scanty rainfall. Anticyclones do not favor condensation and cloud formation. Occasionally, the westerly wind may produce snowfall. The surface conditions of the anticyclone depends upon temperature of the air masses involved, humidity of air and season of the year. In winter, the cold anticyclones originating in snow covered subpolar regions always bring with them very cold temperature. In summer, the air of the tropical or subtropical origin produce extremely high temperatures called heat waves. The range of temperature is bound to be large. Anticyclones are concentrated in two regions: northwestern Canada, east central Siberia, Nevada have the largest anticyclones. A cold Canadian anticyclone which travels from their center of origin to mid-Atlantic states brings cold waves. In Europe, there are only few anticyclones moving southward from the Scandinavian peninsula. The Great Lake regions have maximum anticyclones in summer. Types of anticyclones. On the basis of the structure, storm tracks and general characteristics, anticyclones are divided into the following types. Subtropical high. These anticyclones develop in the subtropical regions, having large areas elongated in shape and very deep in vertical extent. They are almost permanent high pressure centers. They are almost permanent high pressure systems positioned in the high pressure belts. These anticyclones are well developed over the oceans, especially when there is low pressure over the continents. Polar continental high. These anticyclones form over the continental surface in winter. They are produced by traditional cooling of the earth's surface. At about 2,500 meters above mean sea level, they lose their identity. They are made up of very shallow layers of cold air. Conclusion: extratropical cyclones are low pressure systems that occur in the middle latitudes. They have neither tropical nor polar characteristics. They are associated with cold, warm and occluded fronts. They derive energy from the horizontal temperature contrasts that exist in the atmosphere. They are more frequent in winter. On the other hand, tropical cyclones form in the tropics, which can regenerate into extratropical cyclones while they move to higher latitudes. But extratropical cyclones never move into the tropics. Tropical cyclones derive their energy from the latent heat of condensation of the ascending moist air leading to cloud formation. Tropical cyclones originate in summer and early autumn of each hemisphere and have isobars which are more symmetrical and circular than those in the extratropical ones. Tropical cyclones have calm, rainless centers which are absent in extratropical storms. In our next episode, we will be discussing on the tropical cyclones, thunderstorms and tornadoes.